Hello and welcome, everybody. Today we will talk about detecting design errors in Simulink and Stateflow, and also how to generate test cases automatically. I did mute the microphones, and we will have a Q&A session at the end of the meeting. Otherwise, it's hard to organize such a webinar, so please note down your questions and I'm more than happy to answer them at the end of the webinar. I will start with a couple of slides and then we will move to MATLAB. Just for those who might not know who GAMX is, we are the local distributor for the MathWorks. So the MathWorks is located in Natick, near Boston, and they have offices in many locations all over the world. However, in some locations, they prefer to have a distributor who covers pretty much the same services as they do. So we have presentations like this. We also offer licensing, trainings, consulting, pretty much the same services as the MathWorks does. If there are some really specific areas which we cannot cover, then we can ask the MathWorks and they always help us out in those topics. So we pretty much work with them together seamlessly. And the main topic that we will talk about is verification validation today. And based on customer feedback, we realized that a lot of our customers are not aware of some of the key capabilities of the verification validation workflow. So that is why we organized this webinar. But first of all, why do we care about testing? Just a couple of examples. Nissan needed to call back a few million cars because of faulty airbag, or maybe you still remember the Samsung fiasco just a couple of years ago. We want to avoid these kind of issues. The next question is, when do companies find these kind of errors? And the answer is that most of the errors are introduced during the specification. However, they are detected only during the testing phase. So our goal is to match the first graph as closely to the second one as we can. So bring for earlier the error detection. So we want to detect the errors as early as possible. So how does design workflow look like? We start out from some requirements, then we do the design specification, and then we create our model, code generation, and then we deploy. So we have two parts. We have the model verification and we have the code verification. And we realize that on the model verification side, usually people do only testing. However, something is missing. So static analysis on the model side usually is missing from the workflow of our customers. What we will talk about today, we will start out with automatic test case generation. How can we extend the coverage beyond functional testing, what we had. Also, we will do some design error detection, and I will talk a bit about property proving. Why is it useful? How does these tools work? So simulation-based testing, we only test in a couple of dots, but you can see here in the entire design space. Compared to that, formal verification in an ideal case could cover the entire design space. The issue is that there is no ideal case. So in reality, we can cover some of these areas with formal methods, and then we can include some of these dots in the design phase and the design space, and this is how we can achieve a much better testing. Well, this part is what is missing in most cases, in most workflows. Well, just a couple of examples. Why is this interesting? For example, in the case of Ariane 5, they ported some code from Ariane 4. However, because Ariane 5 is a stronger rocket, one of the int16 variables overflow and the rocket self-destructed. Or another example, when the USS Yorktown stopped and could not restart because the speed became 0 and the engine controller failed because a division by 0 error. These are the types of errors that we can detect with formal verification methods. What is similar in these two? So the similarities are that both of these softwares were exhaustively tested. However, still some failure occurred because they could not detect some potential error. Well, in case of formal verification, we can use formal verification on the model level, and we can also use formal verification in the code level. And some of our customers actually are using quite heavily formal verification on the code level, which would look like something like this. So it finds the potential errors in the C code, the resulting C code. However, most of our customers do not use the formal verification tools on the model level. And the reasoning behind it is that why should we use formal verification methods in the model level if we will do that on the code level anyway? And the answer to that goes back to my first slides. We want to detect the errors as early as possible. If we can detect such an error using formal methods during the design phase much earlier, it's much faster and easier to fix there compared to if we find that error only in the production code. So that is our goal for today. So how does this work? We already wrote, let's say, some functional tests, and we get some coverage results. But as you can see, these coverage results are far from 100%. So the goal is we already did the functional tests. However, we want to extend the test cases to achieve 100% coverage. That is our goal. So we start out from our logic. We add the existing coverage to that, and the tool can automatically generate test cases to achieve 100% coverage. Now I will open up MATLAB and do this example real fast. Okay. What do we have here? So we have a state machine inside a model reference. And we have a test harness for it. So this is our state machine that we want to test. In this case, we are using a signal builder block as a test harness, and we have our functional tests here. To get coverage, we go to the configuration parameters, coverage, and here we need to enable coverage analysis. Also, we want to make sure that in the results we select this enable cumulative data collection. The main point here is that we will run several simulations and we want to collect coverage data from all of them. Okay. With this run all button, it will run all 14 or 15 simulations, and it will generate a coverage analysis report at the end. Well, you can see here in the background that still is compiling and running with different input data. Well, as I mentioned, here we will get the initial coverage analysis after the functional testing. So functional testing is always necessary. Based on requirements, we will need to write these kind of steps by hand. There is no way around it. However, the rest of the tests that are required to achieve 100% coverage, that we do not need to write by hand, and usually it's a huge effort to write this kind of last couple of test cases that cover the entire design space. So yeah, that's the hard part, and this is where this tool becomes really handy. Now we are almost done with the simulations, and we will get a nice report, and we can have that in a PDF format or in an HTML format as well. Okay, so we are done with the simulation, and now we can look into the results, the coverage analysis. Well, here we have for each run separately the coverage analysis. It's renamed it, all of them run 14, but this is different run, and here we can see the cumulative coverage. Now the next step, we already have these analyses. We want to extend. So we already created some tests, and we don't want to start from zero to cover all the possibilities. We just want to add some tests to this. So what the next step what I will do is to save this data. So I'm saving now the coverage data, and I will use this data in the next step for the automatic code generation. So the next steps are to set up the automatic code generation. I open up the model, the Stateflow model because this is the model that I want to generate test cases for. And I go into analysis, design verifier, options. So here in the design verifier options, I need to set up the test generation. So I will select that I want to have MCDC 100% coverage, and I also set up that I want to ignore the data that is necessary. So I want to avoid creating test cases for which I already have. That's why I exclude coverage from the previous run. Another thing that I need to set up is that I need to save the data, because later on maybe I want to reuse it or I want to include in my test harness or something like that. So I will save the data, and I would generate separate test harness. Okay. So now that everything is set up, I go to analysis, design verifier, generate test cases, model. So now it will extend my existing test cases to reach 100% coverage. That's the point. Well, as you can see here, the design verifier detected 15 objectives. It needs to generate test cases for these 15 objectives. That's the whole point. And now this will take like a minute or so, and we will get additional test cases. As you can see, this does take a while. However, compared to writing these test cases manually, waiting a minute or two or even an hour, probably it is worth the wait. So it was able to generate test cases to satisfy all 15 objectives. And now we have a new harness model with the additional necessary test cases. So it generated a harness model which has a signal builder block, and inside the signal builder block we have 8 additional test cases that are necessary to achieve 100% coverage. That's the point. And the next step is that we actually want to combine these two together, because if I will run only these 8 test cases, I will not get 100% coverage, because this is only additional to the already existing test cases. So what we want to do is combine the two together. So for this I will use a command So Simulink V and V merge harness. And you mentioned the name of the new harness model and the name of the two models that need to be merged. That's the syntax. Okay. We get a new model. And if I open this up, you can see that here I have all the test cases. I actually opened this example up earlier, so it merged it again. But you can see that here I have all my old test cases, and here I have the 8 new ones. And if I run this, then I will get 100% coverage. Now I will not do this because it will take like another 2 or 3 minutes, but you get the idea. So you run this and you get the 100% coverage, and you get a nice PDF document from it. Our next topic is error detection. So one of the possibilities was, so we could use formal methods to generate test cases. Another thing that we can do with formal methods is to detect, as I mentioned, division by zero or overflow or dead code. Well, let's see how can we do that. Just a moment, I will close down some of these examples because there are too many. Okay. And I will open up a different model. So the goal here is to detect hard to find errors. Some errors that are really easy to overlook even if we do a lot of testing, or we are really confident that our model should be working properly. So this is the model that we're working on, also a state machine. And we want to detect that code for now. So analysis, design verifier, options, and in this case we will use we are interested in dead logic. So design error detection, dead logic. Analysis, design verifier, and in these cases we will do detect design error model. So here the idea is that we do not need any test cases. This error detection is not based on test cases. It just looks our model and tries to find potential dead code in it. So in this case, we have 70 objectives. This is quite frequent to have a lot of objectives in case of state machines. They are really hard to test and really hard to generate, to write by hand test cases so we get 100% coverage. That's why I'm using the Stateflow examples here. Okay, it's done with all the 70 objectives, and we want to find them in the model. The 2 objectives were falsified. We have 2 places in our model where there's that code. I want to highlight it in my model. I open up the Stateflow model, and here in red I see that there is an error. However, I do not really understand why is this. This should work, so I want to debug it. Just to be able to stop it, I will add here a breakpoint. And run the model. So it stopped here the first time when it entered the state machine. And if I come here, I can see that after 5, hold rate and index is 1. So this should work. So why is this that code? And if we go to MATLAB, or even better, let's stick with Simulink and open it up in the Model Explorer. So we have hold rate, and we can see it that the data type is inherited. And if we go to the base workspace, we see that hold rate and increase decrease, there are unsigned int. So because of this, if I go to MATLAB, so hold rate is 1, increase decrease, hold rate is 5, increase decrease is 1. So if it's unsigned int and I write increase decrease divided by hold rate, then this is 0. So here the issue is that I divide 1 by 5 and then I multiply it with 10. However, because of the execution order here, so 1 divided by 5 is 0, multiplied by 10 is still 0. If I would move this 10 here to multiply increase decrease with 10 and after that divide by 5, it would work. So this is a really hard to detect error. The design was perfect, then it moved from floating point to fixed point, it went to unsigned int, and actually it introduced an error. So this is a really good example how can we detect these tools for error detection. Now, similarly to this, we have many other options. We can detect, as I mentioned, division by 0 as well, not just that code. So here we have division by 0 and we have integer overflow as well. And if we don't want to start it from here, we also have the possibility to open okay, so still running. I will stop the simulation. We can find the same thing in the model advisor as well. We know that many of our customers are already using model advisor. However, they do not know of this feature because they don't have access to the design verifier. So in this case, we will have some additional checks for the model advisor if we have the Simulink design verifier. Okay, so we have the model advisor here, and if you select by product, you can see that here is the design verifier, and if I select the design verifier, I will have a couple of checks here. So here is dead logic, here is division by 0, integer overflow. We can select these and run selected checks from here and generate a PDF or HTML report. I will not do this step because it will take another couple of minutes, but if you have Simulink design verifier, you can use it in this way as well for verifying your model. And the last topic, which I will only touch on, is the property proving. I will just close down the models real fast, and I have one more example. So here the idea is that I have my design and I want to prove something. This is not proven with test cases, this is proven with formal methods. So if it says that this will be true no matter what the input, then I can be sure that this is the case. Or if it is not true, it will find an example and it will automatically generate a test case which shows an example. Okay. So property proving, and let's fire up an example real fast. Well, this will be a cruise controller, and the issue with it is that they detected some error, that when they decrease the speed, they press speed decrease, the speed increases instead of decreasing. And they want to analyze this issue. They want to prove that this is impossible, but in this case, actually there is an error in the control algorithm of the cruise controller. Okay. Now here I have my model, and I also have some assumptions. So A means assumption. So in this case, the assumptions are that this is true and this is true, and this is false. And if these assumptions are true, then I want to prove that this will be true as well. So this is property proving. and it works the same way: analysis, design verifier, and proof property model. If possible, it proves that this is correct. If not possible, then generates an example, a test case automatically. So these are the three main topics that I wanted to cover today. So we are already over time a bit. Sorry for that. If there are any questions, I'm more than happy to answer them. So if you have any questions, please unmute your microphone and we are happy to answer your questions. If there are no questions, then thank you for tuning in. If you would like to learn more, check out our other videos and webinars as well, or join us on our training events. Thank you. And if you still have any questions, then contact us on our webpage or via email. Thank you. Bye.